Hello there, and welcome to Physics, Energy and Work. So here, let's start from working out. So in a fitness center or a gym, you have to work hard to keep fit. Lifting weights and pedaling on an exercise bike are just two ways to keep fit and healthy. Whichever way you choose to keep fit, you have to apply a force to move something. So the work you do causes a transfer of energy. When an object is moved by a force, work is done on the object by the force. So the force transfers energy to the object. The amount of energy transferred to the object is equal to the work done on it. For example, to raise an object, you need to apply a force to it to overcome the force of gravity on it. So if the work you do on the object is 20 joules, the energy transferred to it must be 20 joules. So its gravitational potential energy store increases by 20 joules itself. Okay, so if you're lifting a weight that weighs, and the force and the energy required to lift that weight is 20 joules, so you're lifting that weight up against the force of gravity, because you remember gravity forces everything down, then that basically means that the gravitational potential energy store increases by 20 joules. And the formula that we use is here, which is energy transferred equals work done. And that's exactly the example that we just looked at in terms of the 20 joules example. The work done by a force depends on the size of the force and the distance moved. So 1 joule of work is done when a force of 1 Newton causes an object to move a distance of 1 meter in the direction of the force. So to calculate the work done by a force when it causes displacement of an object, you use the following equation. So for example, energy, remember, is in joules and kilojoules. So 1000 joules equals to 1000 joules equals to 1 kilojoules. So in terms of the distance moved along the line of action of the force, we're using the measurements in this case as meters, because meters is the distance traveled. The force applied, remember, force is always measured in newtons, and the work done in terms of energy is something that we call joules. So this is the formula that you're going to use when you're working out a particular energy or work that's particularly done in a certain action. So let's look at this example on the left-hand side. So a builder pushed a wheelbarrow a distance of 5 meters across flat ground with a force of 15 newtons. How much work was done by the builder? So using this example on the right-hand side, we can see that there are 15 newtons of force that were applied over 5 meters. So 50 newtons of force, and force is always measured in newtons, were applied over a distance of 5 meters. And this was the energy that resulted. So the energy that took place, or the work that was done, in other words, was 250 joules. And if you were to calculate that or transfer that into kilojoules, it will basically be 0.25 kilojoules in measurement. So superhuman force. So imagine pulling a lorry over 40 meters on level ground. A pull force of about 2,000 newtons is needed. So this man here in the image on the left-hand side, he's pulling a lorry or a truck, and the energy or the force required is 2,000 newtons in this case. So the work done by pulling force is 80 kilojoules. So over 40 meters. So 2,000 newtons multiplied by 40 meters, which was the distance, 40 meters being the distance, 2,000 newtons being the force applied, resulted in 80 kilojoules. So in other words, 80,000 joules. Very few people can manage to pull with such force, unless maybe you're probably one of the strongest men in the world, or women for that matter. Don't even try it though. The people who can do it are very, very strong and have trained specifically for it. Okay, so this is the main formula that you're going to use for some of the questions based on this particular task on physics, energy, and work. Good luck with this, and we'll follow this up in our next lesson. Thank you.